to begin our integration chapter. I want to get through notes and then we'll see what time we have left. At 11:10, we have to pack up and head upstairs for the dual enrollment presentation.
Oh.
Okay?
That's stupid. I don't like it.
That word's not allowed in my class. Cut it out.
It's dumb.
No.
Moronic.
No.
Say redundant.
It's smart and
Okay, so here's our
Is
gold
buffoonish
sheet.
a word?
Chapter 8 is all about integration techniques. Some of my favorite sections come from this chapter. We're going to start off pretty basic. Today and tomorrow won't be anything mind-blowing,
My mind is always blown.
Hopefully.
but then Thursday and Tuesday we get to do integration by parts, one of my favorite sections in the entire world. Okay? And then we'll do things like trig integration, trig substitution,
Wow.
partial fraction decomposition. L'Hopital's rule is thrown in here. I know you know L'Hopital's rule, but we get to do like even cooler things,
Yeah, I know.
what we did last year. And then improper integrals. Okay? 3 quizzes. It's kind of a long chapter. Okay? Okay.
okay, this goes for a month.
That's pretty scary. I gotta say.
You need to know these two. This one I won't make you memorize, but write it down so you can use it in your homework. But on a test or a quiz, those two that I starred, especially the AP test, they like those. Okay? You know the derivative rules, because I quizzed you on them. But these are the antiderivative rules for them. That is a U on purpose. If you have anything besides an X, you would need to use the U substitution. Okay, and I'll kind of show you what that looks like.
Is there any like memorization tricks?
Well, it's like square root and then switch the sign. Right?
Oh.
You just memorize
Well-
the right side.
You once memorized those derivatives, correct?
Wait.
At one point in my lifetime, I'm sure I remembered it for at least 2 seconds, but that's about it.
Okay.
Are those the ones where it's like square root of like x squared minus 1 or something weird like that? 1 over the squared, like.
Yep.
Yeah.
Well,
So, but here I have U in there just in case. Okay, so let's talk about this. So the derivative of arc sine of x was 1 over the square root of 1 minus x squared, right? Okay, and the derivative of arc tangent of x is 1 over 1 plus x squared. Right?
Yeah.
Okay, so now look at these compared to those. All that we really have to adjust is, well, if it's not 1, if it's not x, we have to account for that. Okay. Tricks for remembering. Arc tangent has a lot of A's, right? Arc tangent has 2 A's. Arc sine has 1 A.
However,
Arc tangent technically has 3 A's there. 4. 4.
Okay.
2 A's, so there are 2 A's.
Wow.
Wow.
that is no cool actually.
I actually thought we would help. No.
I was just excited. Okay. Yeah, point back.
I have 3 integrals up here. At first glance, they all look the same, but they're really not.
Whoa, that's crazy.
Here you have 4 over x squared plus 25. Here you have 4x over x squared plus 25. Here you have 4x squared over x squared plus 25. all require a different technique. So, let's start here. This is the same thing as 4 times the integral of 1 over x squared plus 5 squared dx. Okay. Now I know you wrote it down as a squared plus u squared, but is it okay if we have x squared plus 5 squared?
Yeah.
I
Okay.
guess.
We have commutative property going
Yes.
on, right? So coming back to here, since we have u's and du's, a is a constant, right? It's a 5, right? So this rule is going to be 4 times 1 over a arctangent of x over a plus c. So, to be cool, we could, oops, that's a 5. We can write 4/5 arctangent of x over 5 plus c.
Do you prefer that it's arctangent, not like tangent to the -1?
I don't care. I don't. You will probably see arctangent more than you will see tangent inverse, but we all know they mean the same thing. What about that second one? I'll do it in the color red.
U substitution.
How so? Caleb?
U would be like x squared plus 25. And then it would be like 2x. So it'd be a half moved to the like interval.
Okay. Or you could see that, hey, you have 4x dx, right? But you're right. If we're going to replace x dx, we would replace it with 1/2 du. Okay? Now, let's kind of talk about how we can recognize that this is u substitution, right? I see that my denominator, its derivative, almost matches the numerator, right? It differs by just that leading coefficient, which is easy to adjust. Okay? When you see something, especially with the composition, where its derivative is included in the function, that's a good sign for u substitution. So what we have now is the integral 2 times the integral of 1 over u du. Are you okay with that? Are you okay with my 2? Because we had 4x dx, du is 2x dx, so it comes out to 2 du. Okay, so our antiderivative is natural log of the absolute value of u. But since u is x squared plus 25, you wouldn't have to put the absolute value because x squared plus 25 will always be positive.
Positive.
Okay. The third one.
I would still do U substitution.
How?
Plug in like the relationship between like U equals the X for X. Like, you know what I mean?
I understand.
It's
Yeah,
a
you
very
could
bad
probably
way
do
of probably doing it, but that's what I first thought of.
It's equal to x squared.
That
Those
would
are
be
the long
really hard to
You
do
minus
because you'd have a plus or minus involved when you try to solve for x, right? Like if we try to solve for x here,
So would I have like two
Oh, but
solutions?
you
then?
could solve for x squared, I think.
no, because you'd have 2x dx that you're replacing. So you'd have a 2x left over. And then solving for x here, you have u minus 25 plus or minus square root. Okay, this fraction. What do we call a fraction where the numerator is larger than the denominator? Improper would be the correct term. Very good, Benjamin. Okay, and what can we do with an improper fraction?
We can mix number it.
And we turn it into a mixed number
No.
by dividing.
Please don't.
This is something you learned in Algebra 2.
That was terrible.
And you practice it again in pre-calculus.
It was
X squared times what is 4x squared?
4.
4. And when you take the divisor times 4, you get 4x squared plus 25.
You lost me. You lost me. I'm what?
What's 100?
Times 4.
Oh, okay.
Sorry, I was getting excited.
Oh, so you multiplied that whole thing by 4 and then put them in the proper places there. Okay.
And then what do we do with these? We subtract them, so we have negative 100.
Over x squared is 25.
So our mixed number is 4 minus 100. Well, this isn't technically a mixed number, right? Because we're working with polynomials here, but the idea was right, okay? 4 minus remainder over divisor, 4 plus remainder over divisor. Our remainder is negative, so there it is. Okay, now we can integrate it, right? What's the antiderivative of 4?
4x.
4x. Minus this. Looks like our first one, doesn't it?
Sure does.
Okay, so minus 100 times we have our arctangent rule. So 1 over a arctangent of x over a.
We're from Time Legacy. Did anyone want a magazine?
I'll take one.
There you go. So there's our answer. Okay. Questions?
Why are you smelling it like that? That was just.
Okay.
Unnecessary.
Is right now the appropriate time to start looking at that?
I wasn't looking.
She was smelling.
It does smell funny.
It smells good.
Are there questions on any of these three?
It's like herb.
If the first three questions on your quiz Wednesday looked like these, after some practice, could you do it?
Hypothetically.
Wait.
Yeah.
Wait.
After some practice, keywords there.
Hypothetically.
Wednesday is in tomorrow?
Oh, next week.
Okay, I was like,
time for practice.
Next week, Wednesday.
no thanks.
We still have 10 minutes. We're good. Write this guy down. Yeah, I agree. I mean, I'm not.
What I want to know is like how long it took that guy that found this formula to figure it out.
That guy.
Just that guy.
Maybe
That
it
one
was
guy you
wrong.
never hear about, but he did all that work to sweat out this formula.
Just
And
sweat out the
we
formula.
just took his formula and said,
Caleb,
Dude,
if
Isaac Newton invented
Yeah.
that's pretty much. So when this
What?
it was a girl.
or like in a way, his
Then it was that
responsibility.
girl.
I don't know what like shortcuts he found,
that
but yeah.
human
Okay,
guy.
what does this kind of look like?
Hey.
It kind of sort of looks like that first one we did, except it was the second one.
Okay, so it kind of sort of looks like maybe it has a relationship with this arc sine formula, right?
Perhaps.
Okay, let's talk about it because we have under the square root a number minus an x squared. Okay, let's rewrite this here. This would be 5 squared minus 2x cubed squared. Once I write it like that, do you see a relationship between what I wrote right here and what I wrote right here? Okay, so what we can do is we can say, well, u equals 2x cubed and du equals 6x squared dx, right? So our integral becomes 1/6 integral 1 over square root of 5 squared minus u squared du, which is an antiderivative you have written at the top of your paper, right? Yeah, sorry. You write today.
Yeah.
So we have 1/6 arc sine of u over a plus c. And I'm just going to save some space here. I'm just going to erase u and write 2x cubed instead. Questions, comments, concerns?
I'm concerned already.
You're concerned about what?
Not remembering any of this on test day.
So you just plug in the formula. Right.
Bless you.
You plug it into the formula.
Mhm.
So you pretty much got memorized the formula and then you're good. Right.
Yeah, so both arcsine and arctangent are u over a.
Yeah.
And since arctangent has 2 a's, it also has a 1 over a up front.
Yeah.
It's,
Maybe put it in there.
I think it's more about you recognizing when you can use it.
Okay.
Okay? Yes.
Okay, why is it 1/6 up front, not like 1/5? Because isn't 5 the A?
There's not 1 over A.
Because of our u substitution.
There's no 1 over
Because we replace x squared
That's
dx.
the other one.
Oh, we're using this one?
Yeah.
Oh, okay, that's why it was, yeah.
Okay. So, but we replace x squared dx with du. But we have 6x squared dx, so we had to divide that 1/6 over to replace.
So that's the final answer.
I have confidence. I have confidence
Yes, you do.
that we can do this one.
Well,
Yeah. We can do the X, I believe.
I almost think
You're 1 mile away.
Not even
So there's going to be like some on the quiz that are like trick you where you don't actually have to use a formula. It's just use substitution.
Yeah, like this one,
Like
right?
that. Like it's just
So-
going to be like psych. You don't have to actually use the formula.
Like, I'm just kind of going over, like, different things that we know about integration. Okay?
Okay.
So, Caleb thinks u substitution, right? U could equal what?
X squared.
X squared, because then du is 2x dx. Well, we have x dx, so this would be equivalent to 1/2 integral of e to the u du. Sorry, I had a little trouble. You find me?
Are you in there?
Yeah, Arizona.
So we have 1/2 e to the x squared plus c.
Let's see. I forgot that one.
Don't forget plus c. Ever.
That minus
C.
Aha, that's very funny.
That's how you get a teacher not to like you. Like just do minus C the whole time.
And then never
Or
seen
like
the AC
minus
tests.
like D or something.
Hey, now I want to look at one more example before we pack up and go upstairs. I don't want you to get so stuck into, I need to look for arcsine and arctangent, that you miss ones that don't need it. So right now, I see a square root of 2 squared minus x squared, and that's really cool. But
U substitution.
I have an x upstairs, and I have a quadratic under my radical downstairs. So this would be the perfect candidate, that's all you can do, for U substitution.
Is the perfect candidate?
That was well played.
I'm still voting for Izzy.
Don't do that.
Voting's out right now.
Yeah.
It's go.
You get a vote today during Titan time.
And,
So I already
and, it's,
voted.
and it's electronic.
I'm voting Izzy and Richard. That's just
So this becomes negative 1/2 integral of U to the negative 1/2 du.
It's like a number.
Oh, I should have talked about that. This isn't going to be our last one.
So I need to go up at 10.
It's 11:08.
We can run.
Yeah. We're fast.
We can just forget.
Oh my lord. It's
Form
going too fast.
minus
buddy.
x squared.
Just trust her, okay? Blindly follow her.
just like in real life.
Follow plan.
Truth comes from authority, never question.
Close your eyes.
Yeah.
Richard, what question do you have?
Oh, I don't have any questions. I'm
Just
just
working
writing it
through it.
down.
Just working through it.
Oh, I
I
forgot
wrote
to
it down.
plug in
We'll
U.
look at it later.
It's okay, guys. I have smartable particles.
We plugged in Lisa U,
Yeah.
du.
Smart.
We replaced x dx, but there's that negative 2, so we
Correct.
threw
So it
1.
goes out front.
We have 1 over square root of u, so I wrote it as u to the negative 1/2.
Mhm.
Here's its antiderivative.
Wait, so that's not even using the formulas?
Right. That was the whole point.
Oh, so don't use them when you don't have to.
Exactly.
Got it.
Sorry about this one.
But this one we will need.
Is Ben correct? We need the formulas here?
I don't know.
I think so.
No.
It's not.
Continue, Caleb. You can still use the U substitution.
Okay, so technically we need to
Always.
be upstairs at 11:15. I think we can make it there in 2
I
minutes.
thought she was talking about it.
Okay? This integral is modeled like which one?
Oh yeah, it's this thing.
Second one.
That's weird.
Okay. Now, here's what I want you to be careful of. That's not how I wanted to write it. It is not 1/5 arctangent of 2x over 5.
See?
Oh.
Wait. What?
Because you have to account for the fact that the derivative of 2x is 2.
So it's 1/2.
So it's 1/10.
Yes. Now, some of you will need to do this U substitution. Some of you need to think about it mentally like you just did. Okay? But since this is not plain Jane x squared, we do have to account for the chain rule happening. Okay? So this is 1/2 times 1/5 arctangent of u over 5 plus c, and then we take that u and we replace it with
Work, guys.
2x.
It's so bizarre.
Why is it bizarre?
I don't know.
We should
So we
see the-
only have to do that if it's like not
So that's-
just an x there.
That's
That's
the
b
second
squared.
one.
If it's like a 2x or 3x or
I'm glad that
1/2 x.
Or like last time we had x cubed squared.
Did we do one of these
taught
ones?
myself how to do it.
No.
Makes
You might
it
have one in your homework, but remember that's not one you have to memorize.
Okay.
That's just when you look at that formula that you wrote down. Okay. All right, let me stop this video.
Students do dishes.
I
and
saw one
solves
guy that
AB.
in art is a teacher who's like, he would tell the students that, alright, so this is the equal up here, it's gonna rewrite it.
just went right in for it. The whole thing tipped over.